Okay, let's get into the physics problems. Huh? This will be in the left chamber. I have filled up monoatomic gas. In the right chamber, diatomic gas. Number of moles are given 3 and 5. So initial pressure volumes are 10, and the cylinder is insulated. The gaseous state, what you studied here, little bit different. The gaseous state, what you studied in chemistry here, little bit different. Here our focus will be on the pressure application part. There you are bothered about gas. I'm bothered about what gas can do. That is the approach is what we have to develop from KTG here. Okay, now what do you mean by diathermic and fixed piston? What is the diathermic? Which will conduct heat slowly. Okay, look at the temperature here, 3 T naught, here T naught. So shall I say heat will start flowing? Okay, after some time, after long time, after some time means after long time. Why this? Yeah. You can see this, no? What should happen to the thing, that one? I'm very sure about what? The volumes. Volumes will remain as it is because the piston cylinder, that particular piston is fixed. So therefore the initial volumes of the gas will become equal to final volumes of the gas. This is the initial state. This is the final. Monoatomic gas. This is a diatomic gas. Tell me, like, what shall I do in such a case, that one? What will happen to overall energy? Remains same. So initial energy is equal to final energy. Initial energy, number of moles, N1, F1, R, 3 T naught. This should be equal to, number of moles will not change, no? RT by 2. Finally, what do we expect? What do we expect? The temperature must be same. So the temperature, I'll write T. Any gas will flow? No, only the heat can flow. It will flow through the piston. It will flow from one chamber to another chamber because the piston will not permit the gas to flow. Am I right? Okay, so let's solve for T this one. So this T is equal to N1, 3 N1 F1 T naught N2 F2 T naught. Solving this, the expression for temperature, number of moles 3 into 3, monoatomic gas 3, initial temperature, oh, it should be it should be like this, huh? Number of moles 5, degree of freedom, the atomic gas is 5, the temperature is T naught. Number of moles 3, degree of freedom 3, number of moles 5, degree of freedom 5. Okay, 27 T naught, 25 T naught by 9 plus 25, 9 plus 25, 34. So the final temperature of gas will be 52 by 34, 26 by 17 T naught. Okay, like this, the simple, how to calculate the pressure in each part, here pressure P1, P2. Can we calculate? Number of moles in a given chamber will remain constant. What happened to amount of gas in each part will remain as it is, no? Let me use this space for this calculation. Okay, now let's go for in the left part. Let me write it. Left part. Left part or left chamber. What was the initial number of moles? P naught, V naught, 3 T naught. Should be P1, V naught, T. What is the temperature? 26 T naught by 17. So P1 is equal to P naught into 26 by 17, 3 ja 51, 51 P naught. Similarly, in the right part, P naught, V naught, T naught should be equal to P2, V naught, T. Anybody, can you say anything about pressure? Pressure in the left part decreased, pressure in the right part has increased. Number of moles, amount of gas remains same. That is what we are taking help of it. What will happen to the RMS speed of molecules? Decreases, no? Look at the temperature, T less than T naught. T less than, in fact, less than T naught here. So then here, diatomic gas molecule. So what all it will have, if you look at the diatomic gas molecule, it will be like this. So what all it will have, even root mean square angular velocity also, and it will have RMS speed. So what will happen to those quantities? Let me write omega to V2. With what angular speed now it will rotate? It will rotate with a different angular speed, omega 2 dash. V2 dash, it will be moving. Look at this monoatomic gas molecule. It was moving with a velocity, say some V1. Now it will move with a different velocity, V1 dash. Any reason for that? Temperature has changed. Even the root mean square angular velocity also will change. What is omega 2? Angular velocity with which omega RMS. All molecules will have same angular velocity. No, different molecules will have different angular velocity. Then again, same thing. How we define VRMS here also, root mean square angular velocity. They'll be rotating with different angular velocity. I think we can find out all these things, no? Able to make it out. So one should make observation like this here. Now, what will happen to rate of collisions per unit area? Rate of collisions. Number of moles remains same. Volume of gas in the left part, volume of the left part remains same. Temperature decreased. So rate of collisions will decrease. So what happened to rate of collisions per unit area in both left and right part will decrease. Like this, no, for in every numerical, try to think about all the things: RMS speed, root mean square angular velocity, average translational kinetic energy, what will happen to pressure, what will happen to temperature, what will happen to rate of collision. In every numerical, one has to analyze here.